The definite integral looks like this. What we learned about the definite integral is it has boundaries. It has a and b. If you want to evaluate it, you take big F of b, you subtract big F of a. That will give you the value of the definite integral. I mentioned this before, but the word definite and indefinite, we have definite articles in English, like the. Karina was the winner. Or indefinite indefinite articles like a. So Karina was a winner. What would be the difference between those two? Yeah, one not specific, and it would say that there was only one winner as opposed to a number of possible winners. So indefinite article, we would say, or indefinite integral, we do not have boundaries. It's not bounded. F of x dx. And the way we write this, we do take an antiderivative, f of x. But as we said before, you can have a constant as well. So if I asked you what is the antiderivative or the integral of x squared dx, what would you say? X to the third over 3, and it could be x to the third over 3, or x to the third over 3 plus 2, or x to the third over 3 plus pi. Really, any constant would be an antiderivative, right? Because when you go back through and take the derivative of a constant gives you 0. So that's kind of your piece that you're learning today, but we're going to try some more challenging integrals. I want you to know that taking derivatives is significantly easier than taking antiderivatives. So the reason why your assignment is so lengthy today, you might say, well, gosh, you give us a lot of problems. You need the practice. It's a hard test. These homework assignment problems are crucial if you're successful in this course. So the first thing that you're going to do is you're going to verify by differentiation that the formula is correct. This is suggesting if you were to take the antiderivative of negative x sine of x dx, you would get x cosine of x minus sine of x plus c. Now you don't know how to come up with that on your own. It actually involves something that we refer to as integration by parts. You don't know how to do the reverse product rule, so to speak. Okay? So what we will do is, in order to verify that this is correct, we will take the derivative of this, and what should we come up with? If we take the derivative of this, what should we come up with? Yeah, we should come up with that, right? So let's take the derivative of this piece, and we should get negative x sine of x. How do I take the derivative of x cosine of x minus sine of x plus c? Product rule. Derivative of x times sine of x plus x times the derivative of cosine is negative sine of x. Good. I have a minus sine of x. Oh, I'm sorry. What's the derivative of negative sine? Negative cosine. And the derivative of c is 0. So, cosine of x and negative cosine of x cancel. I get negative x sine of x. And as Allison said, we arrived with the exact same result as what we started with. So we know that the formula is correct. Got that? Yeah. So if I gave you the problem 2x plus 3 is equal to 11, you would solve and get 4. And you would check your answer by plugging it back in, correct? So whenever you get an antiderivative, you can check your work by taking the derivative. And I'll admit, I would say only about 1 in 10 calculus students have the patience to go about and do that. You just have to decide what kind of calculus student you want to be. So when I take an antiderivative, if I'm not sure it's correct, I take the derivative all the time. Excellent masters can always find ways to check their answers. Now this one is a little bit different. What makes this different? Okay, square root. What else? Yeah, you got a couple variables going on there, right? The fact is, because it says dx means that the variable is x, so everything else is a constant. So what this is suggesting, don't write this down, but the integral of the square root of 3x plus 2 dx is equal to 2 over, let's see, a is 3, so it'll be 2 over 9 times the square root of 3x plus 2 cubed plus c. So they've actually given us a formula that if we see something of that form, we could write the antiderivative. In fact, the back of most calculus books have about 200 different rules like this, because finding antiderivatives is significantly challenging. Once you do a difficult one, you would then write the result. For example, I gave an extra credit problem on this test last year, or it was a different test, but to find the antiderivative of secant of x. And you know what? I couldn't do it. I worked really hard. I worked for a while, and I didn't see the trick. Well, lo and behold, there's about 3 tricks, and they're very, very tricky. Right? And so when somebody figured out that antiderivative, they wrote it in the back of the book so people wouldn't have to do it over and over again, but they would have the general form. See the idea? So that's what this is. It's a general form that people would use. Let's verify that this is the antiderivative of the square root of x, ax plus b. So in order to do so, I will take the derivative of that result. What rule do I have to use? And before I use the chain rule, I'm going to rewrite it. 2 over 3a times ax plus b quantity to the 3 halves power plus c. So I rewrote it in a form that I can better understand. What is the inside? Ax plus b. What is the outside structure? Times u to the 3 halves plus c. Derivative of ax plus b. Just a. Think of it if it was 3x plus 2, the derivative of 3x plus 2 would be just 3, correct? So when you don't know, try plugging in some numbers and see what you come up with and make a conjecture. Okay, so the derivative here, I would take the 3 halves and move it in front. U to the what power? 1 half. What happens to the c? Goes away. What do you notice about the 3 halves times 2/3? I'm left with 1 over a, u to the 1 half, times a. Now what happens? A's cancel, and I'm left with u to the 1 half. What is u? Ax plus b, so I get square root of ax plus b. Now I want to be clear that on your test, when you're asked to do this, it's not sufficient to just, write negative x sine of x. I know what the answer is supposed to be. It's not very impressive. I have to see your work, okay? I want to be clear about that. I have to see enough work that you set up the appropriate rule. I have people that consistently on this test, usually about 2 people a year, they simply write down that portion. They look for point. It doesn't work. I get it. You might be confused. You want to at least write something down. So good job. But I will expect you to show work. So let's move forward and practice what we first showed, which is the general indefinite integral. As you notice, there are no bounds on this, so I'm not finding the area beneath the curve. I'm simply looking for the antiderivative of x to the negative 3/7. So it'll be x to the 4 over 7 divided by 4 over 7. So now instead of taking the derivative, now we're doing the antiderivative. And so that can get confusing, but trust me, to be prepared for our section that we see on Monday and Tuesday next week, we're going to need to do that. So plus c, and now I multiply by the reciprocal, I get 7x to the 4 over 7 all over 4 plus c. Where did I get the plus c? Every time you do an indefinite integral, you must attach plus c, and if you don't, you'll have it wrong on the test. Because we weren't taking an antiderivative, we were taking a derivative. See, we were given the antiderivative, and the derivative of the constant was 0. As you can see, these did have a c attached to it. We took the derivative and made it go away. We're going forwards here, we're going backwards here. the indefinite integral. So what we were simply practicing the other day was finding an antiderivative, any antiderivative. And you guys found one. This would be the general form using the indefinite integral. So yes, we practiced this. Okay. In order to do B, what should I do first? So I get 2x minus 6x squared plus 2x to the 6th dx. What is the antiderivative of 2x? X squared minus 2x to the 3rd. Very good. Plus the key is you must write it in the appropriate form. If you don't write it in the appropriate form, you won't know how to take the antiderivative. Our rule applies to power rule. So increase the exponent by 1, divide by the new exponent. So what do I have to do for C? Multiply it out, so I get 2. Negative 2g and positive 3g make positive g. Now I take the antiderivative. What is the antiderivative of 2? 2g. Antiderivative of g. And antiderivative of negative 3g squared. Plus a constant. What's the antiderivative of 2 sine? Good job. What's the antiderivative of 4 cosine? Good. So I'd say the front page is really the most basic examples. Those are ones that we should all get. Let's turn to some more that might give us a little bit of a run for our money. Okay. So, the good news is you've learned it all before, and you learned it a year ago. Okay. So let's look at some trigonometry examples here. Does anybody have their various calculus note sheet on them? You will want to take out your various calculus note sheet. You'll want to have that with you really for the rest of the year. What? You're wearing my jacket. I give it to students all the time. Especially we have underprivileged students who don't have enough clothes to wear during the winter. Offered you a couple times. Like, dude, get this up. Okay. What? Haley, have I ever given my jacket in class? Yeah. Yeah, I know. I sound like a friendly teacher. All right. If you look at this right here, okay? Barry's calculus note sheet. We're going to reference a couple formulas today, and it's so important that as I reference them, you find them on here. Everything that we talk about regarding trigonometric substitutions at this point, you already learned. I don't pretend to think that you, therefore, remember it all. I don't know the secret to getting you to remember all of your trigonometry. I went to an AP Calc Institute a couple years ago, and we were talking about things we struggle with, and I asked if anybody else in the room had problems with their students remembering their trigonometry the following year. Every single hand went up. Like, we don't know what to do. So, what I did was just try to put together a sheet that has the most common trigonometric substitutions and give it to you. So they're sitting in the middle of your sheet, and that's what we will reference at this point. So the antiderivative, the integral of 3 over sine squared of x minus 1 dx. I don't know how to do the problem. Here's a hint. You have to substitute something in here. Close. You have a formula. Sine squared of x plus cosine squared of x is equal to 1. So, Haley is trying to rewrite this, and she subtracts the 1, she subtracts the cosine squared, and she ends up with sine squared of x minus 1 is equal to negative cosine squared of x. Now, if there's one formula you remember on that sheet, I would say it would be sine squared plus cosine squared is 1. Please tell me you remember that. Okay, so you need to sometimes play around with it and switch things around in order to come up with your formula. Everybody clear how I got the negative cosine squared? So, still, it's written as a quotient. It's tough for me to be able to do this. Anybody know a different way I can rewrite this? Very good. The integral of negative 3 secant squared of x dx. Good job. We will tackle that when we get back. Go get some brain food. No, I said 25%. Okay. Hope you had a good lunch. The integral of negative 3 secant squared. So if you look at your sheet, the question is, do you remember what you take the antiderivative of, what you take the derivative of to get secant squared? Tangent. And if you look on your sheet, it's the, let's see, 1, 2, 3, 4. It's the fifth one down. So the integral of secant squared is tangent. No, you can't use it. So that means the integral of negative 3 secant squared is going to give you negative 3 tangent of x plus a constant. How about f? Sine over cosine in this situation. Unfortunately, sine over cosine doesn't work in this situation because you have a 2x. So what we have to do is we use a trigonometric substitution for sine of 2x. Remember from last year you had a double angle formula. Your double angle formula said that sine of 2x was equal to, you have this on your sheet. Very good. 2 sine of x cosine of x. Because that would be too easy. So we have the integral of, if I plug that in, I get 6 sine of x cosine of x. So what happens? Cosines go away, so we have the integral of 6 sine of x dx. What's the antiderivative of sine? Negative cosine. So this will be negative 6 cosine of x plus c. So in order to do some of these, you got to be able to use your trigonometric identities that you have on that sheet. I put them in a nice kind of condensed area where you can always turn to them and see. Should help you all. We got some logarithm stuff there, which we'll use later on. Okay, we'll switch gears. So we just did indefinite integrals. Now we do definite. When you see the numbers, that means it's bounded, and you'll come out with a numerical answer. I made sure to give you something that are challenging. An integral from 1 to 2 of 1 minus cubed root of x over the square root of x. Rewrite it. How? Okay, you have the right idea. That's not correct, but you have the right idea. I'm going to divide each of these. I'm going to divide each of these by the square root of x. I'm going to rewrite this fraction as 1 over the square root of x minus the cubed root of x over the square root of x. Can't do the problem otherwise. I'm going to try to write it as terms that have a power. Right now, it looks like you'd have to use like the reverse quotient rule. It just doesn't work. So, 1 over the root of x is x to the negative 1/2. I can find the antiderivative of that. Then I have the cubed root of x over the square root of x. What do you think? Nope. X to the 1/3 over x to the 1/2, so 1/3 minus a half. What's 1/3 minus a half? 1/3 minus 1/2 is the same as 2/6 minus 3/6, which is negative 1/6. Now I've written it in polynomial form, and I can now evaluate it. What is the antiderivative of x to the negative 1/2? Over 1/2, so times 2. Minus x to the negative 1/6, antiderivative. Close. 5/6 divided by 5/6 or multiplied by 6/5. We will evaluate that at these don't work out well at all, so I'm going to grab my calculator. I'm going to plug this in. .169 minus, plug in 1, you get 2 minus 6 over 5, or 0.69 minus 2 minus 6 over 5 should be 0.8. Negative. And we get negative 0.11. Yeah, how would you check it on your calculator? How would you do that? Plug into y equals, and then do second calculate. Hey, h, got 4y minus 3y to the negative 2. So what's the antiderivative? 2y squared. y to the negative 1 over negative 1, so it'll be plus 3 over y. Plug in the negative 1. Plug in the negative 1, we get 2 minus 3 minus, plug in negative 3, and we get 18 minus 1. Negative 1 minus 17, negative 18. What does that mean? The answer is negative. What does that mean? The area is below the curve, or below the x-axis. Okay, we'll see how smart you are. We'll try a couple trig ones now. That was a sigh. I don't know if it's a sigh of joy of like, oh yay, this is what I was waiting for all day. Okay, 1 plus sine squared over sine squared. I recited the problem. 1 plus sine squared, you can't substitute anything in for it. If it was 1 minus sine squared, then you could. But 1 plus sine squared doesn't work out. I'm going to rewrite it like this. Anytime you have just one term in the denominator, you have a good shot at rewriting it where you divide each term in the numerator by the denominator. This is a common piece that a lot of people wonder about. But if you have 8 plus 4 divided by 2, that's the same thing as 1/2 times the quantity 8 plus 4, correct? I'm showing you. 8 plus 4 divided by 2 is the same as that, right? Which is the same as 8 over 2 plus 4 over 2, right? So you can always take a fraction like that, and if you have one term in the denominator, split it up. Just like 3 over 3 can be rewritten as 1 over 3 plus 2 over 3, right? We're just rewriting the fraction. That's it. Very good. So this becomes the integral from 0 to pi over 4 of cosecant squared of x, like theta, plus 1 d theta. Now, that's much easier to take the antiderivative of. What's the antiderivative of cosecant squared? Negative cotangent theta plus theta. On the AP exam, you won't be allowed to use a calculator for a problem like this. So therefore, you have to be able to evaluate what is the cotangent of pi over 4. And so I will show you how to do that. To make your unit circle, what is pi over 4 in degrees? 45 degrees. So I have a 45, 45, 90 triangle. You remember, we did it this year as well. What is the terminal point for 45, 45, 90? Root of 2 over 2, root of 2 over 2. In terms of x and y, what is tangent? Tangent is y divided by x. So cotangent would be x divided by y. If you divide those two, you get 1, so negative 1. Plus, theta is pi over 4. Minus, now do I plug in? 0. What is the terminal point at 0? 1, 0. Cotangent is x divided by y. Undefined. So therefore, the fundamental theorem of calculus does not apply in this situation. As you notice from the very beginning, if you were to plug 0 in to sine, you would get 0 in the denominator. Therefore, is undefined at your boundary, and the fundamental theorem does not apply. Right. So you'd say FTC part 2 does not apply. I won't give you that kind of a problem in the test, but I do want you to understand that that is a possibility that comes up in calculus. I could have just simply changed this problem to a pi over 6. This could have done the problem pretty easily. But I didn't. We just left it at 0 so that we'd see that occurrence. So we will try more terminal points for J. This will be our last problem. Show me how excellent you are. How can I rewrite this? Everybody is capable of rewriting it. Does not apply. Yep. Why? Signs cancel. Therefore, you have, what is the antiderivative of cosine? Positive sign. Watch, I'll check. Take the derivative of sine. Cosine. So every time you take an antiderivative and you're wondering, oh, did I do that right? Just go ahead and take the derivative. And check to be sure you did it correctly. Okay, my unit circle. Pi over 3, how many degrees? 60. So that makes a 30, 60, 90. What are the sides of a 30, 60, 90? So I have 1/2. Whoop. I have 1/2 root of 3 over 2. And then I've got pi over 6 is how many degrees? 30. So it's also 30, 60, 90, isn't it? It's just the value switch. So I have root of 3 over 2 and 1/2. What is sine the x value or the y value? Sine the y value. So what's the sine of pi over 3? Minus, what's the sine of pi over 6? So I've actually seen this problem come up on an AP exam, and they do not ask you for a numerical answer because you're not allowed to use your calculator. They expect you to list it in simplest radical form. Okay. I know it's not easy, but I do know you can all construct this, right? We did it earlier this year. We did it last year, but we reviewed this year, didn't we? On this test, you can use your calculator. Well, but a warning to you. There are a number of people who are telling me that in college that they were not allowed to use their calculator at all on their calculus tests. I would say about 1 in 6 people are telling me that as they go on the calculator. Yep. So, um, so my encouragement to you is this, okay? If you will be taking math in future years, for example, Haley Larson wants to be an engineer, right? You're going to be taking a lot of math in the future. So I would encourage you to try to do as much of it without your calculator as possible. Because you're going to have some work ahead of you. You don't know what kind of professor you'll get. You don't know the rules that they'll have. So good to be able to do it by hand and then check with your calculator. Good assignment. I know that's what you're waiting for. 5.4, page 357, numbers 1 through 38. A little smiley face. Yep. Um, you do not have to do 15 or 16.